that the Great Pyramid was largely completed by the ancient Egyptians.
Some historians challenge the widely accepted idea that the Great Pyramid was built as a tomb for an Egyptian pharaoh, suggesting instead that an even older civilization may have been responsible for its construction.
Archaeologists in Egypt say they've discovered a 4,000-year-old tomb near the pyramids outside of Cairo.
Elon Musk once fueled controversy by tweeting that aliens might have built the pyramids, adding another layer to the debate. Inside the Great Pyramid, researchers have uncovered numerous puzzling artifacts. Beyond the question of who built it, a bigger mystery remains. What was the true purpose of the Great Pyramid?
The Great Pyramid of Giza is probably the most stunning. How do you think they did that?
Graham Hancock has an interesting perspective. Stay tuned to find out more.
Empire State Building of its day. It reaches 480 feet tall, and for about 4,000 years, it is the tallest man-made structure on the planet.
The Great Pyramid stands as an impressive structure that took around 23 years to complete.
They keep coming up with multiple theories about how the Great Pyramid was built, and none of them make any sense to me. This thing is just a gigantic mystery. You can take the height of the Great Pyramid and multiply by 43,200, and you get the polar radius of the Earth. You can measure the base perimeter of the Great Pyramid, multiply it by the same number, you get the equatorial circumference of the Earth. That number is not a random number.
It held the record as the tallest man-made building for 3,800 years, covering a significant portion of recorded history. Its construction was a massive undertaking, requiring the precise placement of approximately 2 million stone blocks, each weighing an average of 2.5 tons. The engineering techniques used in ancient Giza still leave scientists in awe today. Experts remain uncertain about the exact methods used to build the pyramid. The most widely accepted theory is that thousands of laborers used wet sand to reduce friction and transport massive stones from a nearby quarry, dragging them across the desert on sleds. Some evidence suggests that ramps were used to lift these rocks, but how they managed to position them at the highest points, especially at steep angles, remains a mystery. According to legend, the Great Pyramid holds the secrets of the ancient Egyptian pharaohs. While some of these secrets have been uncovered, new discoveries continue to emerge over time. The pyramids, including those in Giza, may look solid from the outside, but their interiors are mostly filled with a mixture of stones, earth, and rubble. Within these towering structures are several important chambers. Deep inside, there are burial chambers where Egyptian rulers were laid to rest, alongside rooms designed to store their treasures. Some chambers even contain the remains of servants and pets, reflecting the ancient belief in the afterlife and the need to accompany the pharaohs on their journey beyond death. Graham Hancock believes no one really knows how the Great Pyramid was built. He says that anyone claiming to know for sure isn't telling the truth. The pyramid is full of mysteries, especially its massive size and extreme accuracy. It weighs about 6 million tons, with each side over 750 feet long and with a height of over 481 feet. More than 2.5 million stone blocks were used to build it. Even more amazing, the pyramid is perfectly aligned with true north, within a tiny fraction of a degree, something modern builders wouldn't even try to do. Hancock points out that the pyramid's measurements match the size of Earth in a surprising way. If you multiply its height by 43,200, you get the distance from the North Pole to the center of the planet. If you multiply its base by that same number, you get Earth's circumference. This number, 43,200, is not random. It connects to how the Earth slowly wobbles on its axis over time. Now, Graham also rejects the idea that slaves built the pyramid. Instead, he believes that it was made by expert builders who put great care into their work. The way they moved and placed the huge stones remains a mystery, making him wonder if a lost civilization had advanced knowledge that we don't understand today.
Say that they have found a mysterious chamber hidden deep inside Egypt's Great Pyramid of Giza.
In 2023, archaeologists working on a project called Scan Pyramids made a significant discovery. They found a previously unknown chamber inside one of the Great Pyramids, dating back approximately 4,500 years. This hidden corridor, measuring 9 meters in length and over 6 feet wide, was located near the main entrance of one of the 3 pyramids at Giza. Launched by Egypt's Antiquities Ministry in October of 2015, the Scan Pyramids project aimed to study the massive structures without invasive drilling, and this discovery was one of its most important findings. The newly uncovered chamber is situated in the northern side of the Pyramid of Khufu. Archaeologists found this space particularly intriguing because it had no visible entrance. To locate it, experts used advanced scanning techniques, including ultrasound and ground-penetrating radar. These methods revealed the presence of a concealed corridor. To get a closer look, researchers inserted a miniature endoscope through a small gap into the pyramid stones, capturing the first images inside the chamber. Inside, they found two large limestone blocks, raising the question of what might be hidden behind them. Egyptian antiquities officials believe this discovery could lead to even more revelations. One theory suggests that the unfinished corridor was designed to redistribute weight around the pyramid's main entrance, which is frequently visited by tourists. Another possibility is that it leads to an undiscovered chamber, adding yet another mystery to this ancient wonder. This recently identified chamber isn't the only inaccessible space inside the Great Pyramid. Another, much larger void is concealed deeper within the pyramid, positioned directly above the Grand Gallery, the long, narrow corridor that leads visitors to the King's Chamber, one of the 4 accessible rooms inside the structure. This space is referred to as the Big Void, a name given by the scientists who first detected it. What sets this big void apart is that it's entirely encased in solid rock, making it impossible to reach physically. However, by using non-invasive scanning techniques, researchers estimated its size to be several hundred cubic meters. Although the discovery was made in 2017, the Big Void has remained mostly unexplored due to its central placement within the pyramid, which makes studying it a significant challenge for researchers. The Big Void presents a complicated puzzle. Its deep position inside the pyramid makes obtaining precise measurements difficult. At this stage, it remains unclear whether it's a hidden chamber, a construction anomaly, or something else entirely. One fact remains certain. It's a large space that deserves further examination. A thorough investigation of the Big Void would likely require making structural modifications to the pyramid itself, a task that must be approached with extreme care. Creating an opening might be necessary to insert more advanced scanning equipment, but any such action would need to be carefully considered to ensure the preservation of this historically significant site. Based on the data collected so far, archaeologists have suggested several possible explanations for the Big Void's purpose. Initially, some believed it functioned as a relieving chamber, meant to reduce pressure on the Grand Gallery below. However, this idea was ruled out after experts ran simulations, which showed that the void's position, approximately 10 meters above the gallery, was too high to provide meaningful structural support. Another theory proposed that it could have been a second Grand Gallery, used by builders as an internal passageway. Over time, this passageway may have become sealed off. There's also speculation that it might have been an ancient anti-seismic chamber, designed to mitigate the effects of earthquakes. If true, this would highlight the ancient Egyptians' advanced understanding of engineering and their efforts to protect their monumental structures. Additionally, within the Great Pyramid, there are smaller cavities that continue to puzzle experts. These narrow shafts, roughly 30 centimeters wide, connect to both the King's and Queen's chambers, yet they're too small for a human to pass through. Despite multiple robotic explorations, their purpose remains unknown. These features represent a lingering mystery that future researchers may eventually unravel, offering new insights into this extraordinary ancient monument. Tomb, observatory, or something else? Despite roughly 150 years of Egyptology as a formal academic field, scholars have yet to agree on the true purpose of the Great Pyramid of Giza. Many different theories have been proposed, each presenting a distinct interpretation. One of the earliest ideas was the tomb hypothesis, suggesting that the pyramid was primarily built as the final resting place for Khufu, the second ruler of the 4th dynasty. There is some supporting evidence for this, such as the existence of a burial chamber believed to be meant for Khufu. However, some Egyptologists have challenged this explanation, arguing that the Great Pyramid's design is far more intricate than what would be expected for a simple tomb. A particularly perplexing detail that many theories fail to account for is the pyramid's proximity to the geographical center of the Earth. This precise alignment raises questions. If the pyramid was intended solely as a tomb, how did Khufu determine this location? Did he or his builders conduct extensive mapping of the planet as part of the construction process? This leads to another mystery. How long would it have taken to chart the Earth accurately enough to pinpoint this exact site? Due to these unanswered questions, some researchers believe the Great Pyramid served a purpose beyond being a tomb. Some suggest it might have been a religious site or a celestial observatory, playing a role beyond what is typically associated with burial structures. The idea of pyramid power first appeared in the 1930s, suggesting that the shape of the pyramid could have beneficial effects on mental and physical health. However, the theory that the Great Pyramid functioned as an actual machine was introduced in a book called Pharaoh's Pump by Edward L. Kunkel. Kunkel proposed that the Great Pyramid operated like a hydraulic ram pump. This type of pump works by using changes in air pressure to push water upward through the pyramid and out through the small shafts. Essentially, Kunkel described the pyramid as a massive version of the hydraulic and pneumatic water pumps later developed by Heron of Alexandria, a mathematician and engineer known for his inventive work in ancient times. His theory connected Heron's innovative water pumps with the advanced engineering of the Great Pyramid, offering a unique perspective on its possible function. As Kunkel's theory was tested and refined, researchers suggested that the pyramid might have functioned as a vibrational pulse generator. This idea was based on fluctuations in both air and water pressure. The theory proposed that when water entered a specific chamber inside the pyramid, known as the subterranean chamber, through the descending passageway, pressure would gradually increase due to the use of granite check valves. Once the pressure reached a critical level, it would generate a vibrational pulse. These pulses were thought to create a steady rhythm of vertical compression waves that moved through the pyramid structure. Expanding on this idea, later theories proposed that the pyramid might have functioned as a chemical reactor system, or even a microwave laser. According to this theory, the repeated compression pulses could have been used to convert sound energy, using hollow clay resonators into electromagnetic energy. Some scientists speculated that the ancient Egyptians might have utilized this electromagnetic energy to operate different machines and tools, potentially including high-speed rock saws and other advanced technology. In 2018, researchers discovered that the Great Pyramid of Giza had the ability to collect and focus electromagnetic energy within its chambers and in its base, hinting at additional unknown functions. One theory suggests that the electromagnetic fields generated or collected by the pyramids could have played a role in fertilizing the Nile Valley. This idea raises an interesting question. How might these fields have been used? Some scholars propose that the pyramids could have harnessed these fields, which are a form of energy similar to radio waves, but at very low frequencies. This might seem unusual, but there are similar structures in other parts of the world. In Ireland, for example, tall cylindrical towers resembling pyramids in some ways have been found to capture and concentrate a special kind of energy produced by global lightning strikes, specifically low-frequency radiation. These towers directed this energy into nearby fields, improving crop growth. The theory suggests that Egypt's pyramids could have worked in a similar way, using the electromagnetic fields they generated or collected to support agriculture by enhancing the fertility of the Nile Valley. This perspective adds another possible function to these ancient structures and highlights their potential role in sustaining Egyptian civilization. Now let's look at another interesting theory about the Great Pyramid of Giza. Some believe it had a special function of releasing free electrons into the ionosphere, which could have created light on Earth. This might seem like a far-fetched idea, but let's break it down in a simple way. Light can be produced by any system that sends charged particles into the ionosphere, a layer of Earth's atmosphere. You've probably heard of the aurora borealis, or the northern lights. This natural phenomenon occurs when electrons from the sun collide with air molecules in the ionosphere, creating beautiful lights in the sky. Now, some researchers think that the Great Pyramid of Giza might have been capable of producing a similar effect. But how could it possibly do this? The theory begins with the materials used to build the pyramid. If someone in ancient times wanted to create a system that emitted electrons and produced light, they would need to choose the right construction materials. The key would be finding a material that conducts electricity efficiently at high frequencies. Copper is an excellent conductor, and the ancient Egyptians had access to it. However, copper has a drawback. It heats up and melts quickly when exposed to high frequencies. So, what other metal could work? Now, this is where things get interesting. Scientists from the National Research Center in Cairo studied a type of limestone called Namultic limestone, found in the Abu Rawesh area. Their findings were surprising. This limestone demonstrated exceptional conductivity, especially at high frequencies. In fact, if someone needed a material with a conductivity of around 600 terahertz that was also strong and durable, this specific type of limestone might have been the perfect choice. As we mentioned earlier, the fact that the Great Pyramid is located precisely at the geographical center of Earth is fascinating on its own. But let's go further and see why this location might have been crucial for a structure meant to emit high-frequency radiation. For any system to efficiently emit electromagnetic radiation at high frequencies, it needs to be surrounded by a large landmass. This is a basic principle known to engineers who design antennas. Now, imagine that the pyramid's function was to send electromagnetic radiation across the entire planet. If that were the case, being positioned in a location with the greatest amount of surrounding landmass would be ideal to make it work effectively. The electrons released by the pyramid would need to reach the ionosphere, which is roughly 100 kilometers above the pyramid's peak. Think of Earth as a giant spherical capacitor. That might sound complicated, but it simply means that high-frequency electrons can move through the air with very little resistance. Additionally, the ionosphere itself does not provide much resistance to these electrons. So, picture these electrons traveling up through the air, reaching the ionosphere, and then moving across this layer with little interference to the other side of the planet. However, there's a challenge. For the process to be completed, these electrons would need to return to the base of the pyramid. As they travel through the ionosphere, they collide with gas atoms, creating something similar to the aurora borealis. Once they begin their journey back to Earth, they take specific routes through elevated points on the planet. You might be surprised to learn that many ancient cultures built pyramid-like structures in different parts of the world. These pyramids could have acted as pathways for electrons returning to the Earth's surface, creating an intense display of glowing light above them. But how do these electrons make their way back to the pyramid's base? They follow a unique path through the planet's mantle. Luckily, the mantle offers very little resistance, allowing these electrons to return with ease. Now, let's look at what happens as these electrons move toward the Giza Plateau, where the Great Pyramid stands. They pass through water-filled caves, triggering a process called electrolysis. This reaction splits water molecules into hydrogen and oxygen gases, which then accumulate in the caves, increasing pressure on the bedrock. The result? Vibrations and underground rumblings create both the physical effect and audible sound. Now let's examine the functions of the Great Pyramid of Giza and how it may have been capable of generating light. The theory suggests that different elements within the pyramid played key roles in this process. First, let's focus on the subterranean chamber. This chamber is believed to have been essential in splitting water molecules into hydrogen and oxygen gas, a process that required water terminals and voltage. Since hydrogen was needed for light production, oxygen had to be removed from the system. The subterranean chamber's design appears to have been carefully planned, featuring two limestone hills that acted as terminals. Notably, the left terminal is wider than the right one, allowing more electrons to pass through it and creating a voltage potential. The right terminal, which is smaller, became the negative side, where hydrogen gas gathered. The subterranean chamber also has two shafts, one on the left and one on the right, positioned at different heights. Hydrogen, being lighter than air, would naturally rise through the right shaft and move toward the ascending passage, while the heavier oxygen would settle at the bottom of the chamber. A granite block placed on the floor of the right shaft would prevent oxygen from escaping, while allowing some gas mixture to move through. This wouldn't cause combustion. Instead, the gases would accumulate in the caves and release with high pressure, creating a powerful reaction. To produce light, free electrons were needed, and hydrogen was thought to be the source. These electrons could be obtained by compressing hydrogen, exposing it to high voltage, or subjecting it to electromagnetic radiation. It's believed that all three methods were used within the pyramid. As air pressure in the subterranean chamber increased, hydrogen gas was forced into the Queen's chamber, filling the northern and southern shafts, which were blocked by granite bricks and doors. As pressure built up, the gas heated, partially releasing electrons. Copper terminals embedded in the doors were positioned to capture electromagnetic radiation from stars, aligning with the shafts. The alignment didn't need to be exact. It only had to allow X-rays and gamma rays to reach the copper terminals, initiating hydrogen ionization. The King's Chamber is believed to have played a role in collecting the free electrons generated by the Queen's Chamber and directing them toward the top of the pyramid. The granite beams in the King's Chamber, made of red granite, have a high crystal content that, when exposed to vibrations, produce an electric field. This field pulled electrons from the Queen's Chamber upward. The portcullis in the antechamber regulated the flow of hydrogen gas into the King's Chamber and controlled the pyramid's internal pressure. When closed, it would prevent gas from escaping through the King's Chamber shafts, ensuring controlled light production. Now let's take a look at the mysterious coffer in the King's Chamber. Its purpose has long been debated, but according to this theory, it was essential for generating high voltage within the chamber to ionize hydrogen and make the space conductive. Without a high-voltage source, the pyramid's light-producing process would not work. Some suggest that a device similar to the Baghdad battery, or one resembling the construction of the Ark of the Covenant, may have been used for this purpose. Finally, there are 3 granite plugs in the ascending passage, which are believed to have served as an emergency stop mechanism for the pyramid's operation. These slabs could be slid down the descending passage to block hydrogen flow and shut down the process. There's even speculation that they were used at least once, adding another layer of mystery to the pyramid's history. Much remains unknown about the Great Pyramid of Giza, and this image only deepens the curiosity. It shows a large pyramid-shaped structure beneath the Great Pyramid. The surface appears smooth and polished, positioned between 2 towering pillars. Inside the cave, there's a vast open space illuminated by the light from the pyramid. Even the pillars appear to emit a glow. Looking at this scene, you might find yourself questioning many things. What do these mysterious structures inside the cave represent? And could this pyramid have a connection to the Great Pyramid of Giza? Thanks for watching. We'll see you in the next one.